So, as I was mentioning, as the voltage levels go up from the extra high voltage to ultra high voltage, the pollution or a contamination flashover is of a very important, particularly during the consideration of the design aspect of an insulation. So, the pollution or a contamination flashover studies have to be carefully carried out before the insulators are erected in the field, or with the string is being erected in the field conditions to the tower. So, how is this pollution threat and why it is an important factor? So, the reliability as mentioned, as been discussed for the modern high voltage power transmission system has been seriously affected by the pollution or contamination induced flashovers, which important point I would like to stress is occurs at normal operating voltage itself. So, the normal operating voltages. So, we are not saying the lightning surges, we are not saying the switching surges, we are not saying the power frequency over voltages, but the contamination or a pollution induced flashover could occur at normal operating voltage. So, this is a serious concern. Just by looking into the graph, you can see the flashover voltage versus the time of flashover. Here an example I have shown here for a 220 or 230 kV operating voltage. 186 kV is the minimum operating voltage for a 220 or 230 kV system. 206 is the actual operating voltage. For a 220 kV system, 1.2 by 50 microseconds is the impulse voltage or a lightning surge which an insulation has to be applied. So, for dry conditions, a 1275 kV is applied where the insulation withstands. So, no problems. Then coming back to switching surges, which are because of the opening and closing of the circuit breakers. The switching surges or switching impulses are typically of 250 by 2500 microseconds duration. So, switching surges will normally be of magnitude somewhere around 875 kV in case of dry and 750 kV in case of wet condition. So, the 230 kV insulator string normally undergoes lightning impulse voltage levels, switching impulse voltage levels both for dry and wet conditions, does not have any problems with that. But when you follow the line here, the third line, the polluted conditions, you can very clearly see that the flashover voltage over a period of time, this is a time to flashover, this could happen at normal working voltages. So, the pollution insulation level could come down to the normal working voltage. So, this is a serious threat where the flashover at working or a nominal voltages for a porcelain or a glass insulator under contaminated conditions could happen without any surges, where the surges lightning or a switching surges without any effect of the lightning or switching surges. So, considering this very important, the high voltage laboratories have to see that the pollution facility has to be developed and suitable performance have to be carried out under polluted conditions for various polluted zones. So, a pollution or a contamination when we are discussing again will have various types of pollutant as we discussed. The pollutants, in case the transmission towers are passing near the sea coast, the pollutants may be because of the salts from the seashore which are being carried out by the wind and gets deposited on the insulator surface. There could be a industrial pollutants in case the transmission towers run near the industrial areas. An example, if there is a cement industry, the cement dust gets collected on the transmission insulators over a period of time. Similarly, in case of desert sand which is highly conductive in some of the countries. So, this desert sand also gets accumulated on the insulator surface during humidity, become wet, and the surface starts conducting. So, this is again desert pollution is also important factor to be noted. Mixed pollution, again mixed pollution could be the transmission line running both near the industry as well as a sea coast, or it could be in the desert where the industries could be there, or it could be because of the any combinations. So, such pollutants also gets accumulated on the surface over a period of time. Then the pollutants could be due to the agricultural activities. So, agricultural activities, particularly plowing of land, using pesticides, by employing mini helicopters for spraying in the fields. These chemical vapors or pesticides or agriculture activity related pollutants go and settle on the insulator surface and could again because of the mist or fog or during the rain becomes conductive and could be a contamination or a pollution flashover could happen. Similarly, fog or ice, this again happens in the high altitude and the countries where ice loading is seen on the transmission tower. This could again become impediment for the smooth functioning of the insulator, where the pollution or a contamination flashover creates a major hurdle for the transmission or utility engineers. So, apart from this type of pollution, we also come up with the forest, where the transmission lines run across the forest. Huge trees and branches have to be regularly trimmed, where the flashover could happen because of the branches coming in contact with the live transmission conductors. Then we also see the bird related flashover. The excretion of the bird is a highly conducting fluid. So, when the birds take shelter on the transmission towers during their depart, so there could be a high excretory thing which could be a conducting fluid comes in contact with the true transmission conductors, a flashover could be happening. So, this again also is a threat to the transmission lines and the utility engineers have to be looking into this aspect as well. So, similarly we have various types of pollutants in the industry where they get accumulated over the period of time and degrade the properties. How this pollution flashover happens, basic phenomena. So, just to explain the physics of this in a brief manner, the initially as mentioned, the deposition of the pollutants could be contaminants or pollutants could deposit over a period of time on the insulator surface depending upon the transmission lines which pass near that areas. In case of industry, the industrial pollutants; in case of the towers or lines passing near the sea coast, the sea salts could be the pollutants, or agriculture fields, the agriculture activity related pollutants could go and settle on the surface of the insulator over a period of time. Because of the pre-monsoon conditions or because of high humidity, this becomes wet. So, mist because of fog, because of light rain, surface becomes wet, and heavy rain is a complicating factor. So, it could even wash the pollutants on the surface of insulator and the flashover may not happen, or it could also bridge the flashover between two shades. So, rain is a complicating factor, but fog, dew, light rain, mist is very unwanted or dangerous event which could trigger the pollution flashover on the surface, because this wets the surface and the surface becomes conductive and the flow of a leakage current starts on the insulator from the conductor towards the ground end. In case number of insulators, the surface condition dictates the flow of current. So, because the pollutants or the contaminants which are collected on the surface are not of uniform in nature, They could be because of the wind flowing in particular direction, the contaminants getting accumulated on the surface is not uniform. Some of the areas could be more, some of the areas could be very less, and some area of the insulator no pollutants may not be also deposited. So, here because of this non-uniform distribution of the pollutants on the surface, when the surface becomes wet, the leakage current starts flowing. Because of non-uniform nature of the deposit on the surface, the current which is flowing also is of non-uniform in nature, and there will be a formation of wet and dry bands. The area where wet band is the flow of current where the pollutants are accumulated, and dry area where the pollutants are not existing. So, here because of this non-uniform dry band wet band formation is happening, and non-uniform heat generation and non-uniform drying of the insulator on the surface of the insulator happens. Here because of the wet and dry bands formation, non-uniform heating, a small discharges across these dry band wet bands. Dry band normally conduction across wet band conduction happens, dry bands there will be a small arcings which we normally term it as a partial arcs or a scintillation, small discharges which are not of continuous in nature, depends on the magnitude of the surface currents which are flowing and also the surface wetness. So, the inception of scintillation or a partial arcs take place. This activity goes on till the surface conduction on the insulator surface. These partial arcs or scintillations which could elongate depending upon the voltage stress and the surface condition of the insulator, and it has been observed the complete flashover or bridging of the entire insulator could happen where the entire line trips in the substation. So, this phenomena is normally observed during the pre-monsoon conditions. So, the pollution flashover or a contamination flashover is a phenomena which could happen over a long period of time and has to be properly addressed. Several types of insulators are being used as mentioned, ceramic, glass and polymer. So, there are several methods to overcome this pollution flashover. Some of the methods are also being developed to see the pollution flashover is delayed or improvement for the existing insulator is happening. So, this shows the schematic of how the pollution deposits the wetting of the surface, then the dry band arcing, small arcings which take place, and further depending upon the surface condition the entire flashover happens across the insulator string. So, pollution or a contamination flashover is the which we have discussed is a phenomena very complex in nature. It is very difficult to theoretically calculate or to have a model where theoretical calculations could be done, because it involves several factors, type of contaminants, the spread of contaminants, the thickness, the wind, the moisture, several types are involved. So, the flashover of a contaminated insulator is itself a very complex phenomena. It is also mentioned earlier, it is a relatively very slow electrothermal process. The time which could happen, when it could happen is totally unpredictable. It could happen over a period of time, few hours or much more than that. So, that is one of the reason the process is electrothermal in nature, both temperature and electrical stress. So, continuously exact simulation in the laboratory is also equally difficult. So, experimentation also it is difficult to simulate the actual condition. And the influencing parameters as mentioned are the wetting rate of the insulator, whether mist, fog, light rain, drizzle, the pollution types, what type of pollution or a contamination which is spread on the surface of the insulator, the wind and its direction play also a role. Some of the pollutants could be carried away by wind, some could be again deposited on the surface, and what type of insulator is being employed for the transmission at that particular zone. So, all these are the factors which influence the contamination or a pollution induced flashovers across the insulator string, particularly at extra high voltage and ultra high voltage transmission, which is of a very serious concern. So, for this some remedial measures do exist for the silicon for the ceramic or glass type of insulators. There are coatings like a silicon grease, room temperature vulcanized rubber coatings, resistive glade coatings. Sometimes the utilities go on increasing the creepage lengths and going in for special designs, live line or hot line washing of insulators before the pre-monsoon conditions. So, these are several methods being followed by the utilities to see the pollution or a contamination flashover does not happen at EHV and UHV levels. There is also some work which has been carried out to suitably mitigate these techniques, which is cost effective and gives better performance in the field. So, effort was made to develop a special field control electrodes or a field control elements to reduce the surface field. It has been seen that to enhance the pollution flashover strength is mainly to reduce the maximum surface field. So, this observed in the field and experimentation, we have come across that the maximum surface stress occurs at the pin junction at the high voltage end. So, the innovative solution to solve this problem mechanically could be the extension of or the dimension of the pin without affecting the clearances, without significantly sacrificing the creepage distance. That is, the creepage is metal to the cap, the distance between the metal to the cap is known as the creepage distance, without amplifying the bulk stress in air. So, several of these things have to be taken, and also the mechanically the insulator has to have a rugged addition. So, we have tried to theoretically as well as experimentally try to come up with both a simulation and an experimental arrangement by establishing a special experimental facility for the pollution studies on insulator strings, and we have developed a novel field control element particularly to improve the flashover of insulator during a contaminated or a pollution conditions. This work mainly focuses for the ceramic disc insulators. So, we have carried out theoretical investigations where we have assumed the governing field as a electrostatic, particularly for clean conditions, and steady conduction under the contaminated conditions. So, the theoretical investigations we have used the governing equation as a Laplacian with complex permittivities, particularly for the combined fields. So, simulating the method or developing a model using analytical methods is impractical because the geometry of this insulator is so complicated, it does not fit into the orthogonal curvilinear coordinates. So, going in for analytical methods is a tough procedure, or it involves a lot of analytical methods, and it is really impractical. So, hence a numerical approach has been followed for the method which we have adopted. So, the insulator being of open geometry, we have used a boundary based methods which are normally suitable because of the insulator consists of multiple dielectrics, that is the metal, the ceramic, the porcelain, Portland cement, and again the metallic cap and a Portland cement. So, this has a multiple dielectrics, hence we have chosen a surface charge simulation method for the numerical simulation aspects, and we have tried to develop a 2-dimensional axis, because the insulator is an axis symmetry model, could be considered as axis symmetry model. So, we have developed a computer codes for the surface charge simulation method particularly looking into the effect of pollution conditions and the surface conduction field which dominates over the conduction period. So, the profile of the insulator assumes very important, prime important. This is a metal pin junction, this is the cap, and this from here to is the creepage or the petticoat region which has been shown here. So, this we have tried to carefully counter the pin area, and we have successful in developing electrode for the various ceramics discs which are being used in the country. We have modeled the high voltage, including the high voltage conductor, cross arm arcing horns. Many of these things have also been taken care, and we have seen the reduction in maximum surface is very important, which is essential for improving the pollution or a contamination performance. So, the maximum surface stress, as mentioned earlier, will normally occur at the pin region because the pin is at high voltage potential. The pin which is connected to the ceramic disc, again with the help of the Portland cement, is a weak junction where the scintillations or the partial arcs start occurring, and the discharges or the partial arcs or the scintillation near the pin region, in case if they are reduced, the ultimate flashover could also be reduced, and the insulator could perform much better in the field for pollution or a contaminated areas. So, in innovative solution, we have tried to see that the pin of the insulator has been suitably modeled without affecting the air clearances, without significantly sacrificing the creepage length of the insulator, without amplifying the bulk stress in air which could deteriorate with the corona inception voltage, and the component which we have developed is also mechanically rugged in addition. So, an intuitive approach has been employed iteratively with the field solution, and simulation aspects has been conducted. The actual data of the manufacturer of the insulator dimensions has been taken, and it is transferred to the code where discretization initially for the single disc is performed, and later on for the string global discretization is carried on. The corona control rings, the top and the bottom conductors are also appended in the program, and the data is written in a file with a specified format. A special code has been written to see the to obtain the potential, field, bulk stress, many of these things. So, we have based on the simulation for various types of insulator discs which are used for EHV and UHV levels in the country. So, various manufacturer data has been obtained, and we have tried to develop the field control element for the insulators, for different insulators, and this is how the field control element, which consists of two types of electrodes, will be used to fix near the pin junction to improve the pollution performance, where it increases the surface field there, the scintillations or partial arcs which are being seen at the inception have been completely reduced, and ultimately the flashover performance of the insulator in case of all the types of insulators, 10 different types which are used for EHV and ultra high voltage, have seen an improvement with the using of the field control element. This is the potential distribution for different types of insulators. We have also tried to simulate the bulk stress, the point where the insulator could be of high stress zone. So, the potential, the electric field and the bulk stress have been simulated for various insulators and various strings for up to 400, 765 kV and all. This gives an equipotential plot for a 400 kV transmission tower consisting of 23 discs. This shows the bulk stress, that is the volume stress which is seen for the insulator string in case of 400 kV for one type of disc insulator. Similarly, several types, that is 10 types of disc insulators which are being employed in the country have been used for the simulation, and suitable integrated with the field control element, and the improvmental aspects have been shown. So, this shows the surface potential profile for a particular type for the normal condition and with the field control element. We can see without the blue color shows the potential of a single disc. The single disc we have applied 11 kV, this is the pin region, this is the petticoat of the insulator or the sheds, and finally this is the cap which is at 0 potential. You could see the distribution of the potential without the control element which the design control element is showing. The red color indicates the potential distribution with the field reduction electrode which we have developed. This very clearly shows the field. It is exactly the mirror image here, surface field profile for the same insulator. You can see the blue color which is a very high 8 kV per centimeter is the electrical stress which is sees for 11 kV. With the introduction of field control electrodes, the stress comes down to 2 to 2.5. This very clearly demonstrates once the field reduces near the pin junction, the inception of scintillations gets reduced. Ultimately the insulator will never have more stress, and the flashover which is happening will also get completely reduced. So, we have tried to carry out for various type of discs which are being employed in the country. So, and try to simulate the field control elements and practically used for all the type of insulators. A laboratory has been established keeping this in view, 150 kV 300 kVA source with a 5 meter cube of the pollution or a contamination facility where insulator strings could be erected inside the chamber. This is the from the bushing of the transformer, a special high voltage lead is taken inside the chamber consisting of the fog nozzles, and the pollution facility consists of 5 meter cube chamber where the experimentation is carried out for various types of discs. So, the procedure as per international standard is being employed for the ceramic insulator disc, and the pollution or contamination coating is normally carried out. Verification of the insulator, the flashover performance for a normal string, and also the strings with the field reduction electrodes have been carried out and successfully demonstrated for string consisting of a single disc to 3 discs in a string. So, you could see the scintillations which happen and the voltage levels where the scintillations or partial arcs or the discharges happen. This is the high voltage conductor, this simulates the tower. You could see the discharges particularly near the pin and surrounding the pin region, the cement region which are of significantly seen. As the voltage level increases, the scintillations or the partial arcs starts higher and they could again bridge the single disc. Further, this bridging could create non-uniform voltage distribution across the entire string, and the flashover of insulator could be seen. This is similar to the field where of same phenomena could happen in the field. So, lot of experiments have been carried out for the normal string and the string containing the field reduction electrodes which have been developed in the laboratory. We have tried to see various configuration for a double tension arrangement, a single type of insulators. A comparison you can very clearly see here, the insulators containing the field reduction electrodes, the flashover has not happened, whereas without the field reduction electrode, the flashover has been noticed. So, this shows that the element or the field control element which has been developed will be helpful for the ceramic disc insulators to see the pollution flashover phenomena does not happen.